everyone. I hope you all are doing well. This side Priya Bhatia, and in this specific video, we will be discussing about how can we handle the outliers in the Excel tool. I hope that you are already aware about what are outliers in a given data and why it is very essential to handle those outliers in an efficient manner, right? Now, whenever we're talking about outliers, many people have that assumption that we can handle that specific part via creating a box plot, which is very much apt. But the way to do that specific thing is via Python code, which is quite famous, right? We load the data entirely into data frame. Then we try to use the frameworks like matplotlib and seaborn to create the box plots. Obviously, prior to that, we will do a lot of data pre-processing part, and then we will try to remove those outliers, or we will try to do the imputation depending upon what kind of scenarios we are dealing with, whether we have a abundance of data or whether we have a limitation or limit part of a data set. Accordingly, we will try to handle it in an appropriate manner. That's the whole idea, which I think many people have already opted in the company's work whenever they want to handle the data in an efficient manner, right? What is special in this video? What we will do in this video is we will try to see that apart from the coding part per se that we already know, right? How can we handle this with the help of an Excel tool? Yes, we have functions in Excel with the help of which we can easily able to handle these outliers in an efficient manner. Many people might not be aware about this. So that is where please try to listen this video till the very end. You will get a lot of insights. For all those people who are not aware about what is IQR, what is box plot, in the very first portion of this video, I will try to convey those concepts with the help of one dummy example so that understanding is very much clear for all those people also who are not from this background. Followed by, I will try to showcase you the implementation via the Excel tool. We will take some dummy records. I will try to create a box plot for the same. I will try to showcase you what are the important functions we have with the help of which this is quite feasible, right? So I hope that you find this video quite insightful. And with this, let's get started. Whenever we are talking about handling of outliers, it's really important to understand the dispersion methods that we have in stats, right? So if I'll ask from you, how many number of dispersions, right? The spread of a given data, how you can measure it, how many methods that we have, or you are aware of, can you just pause the video and list down few of them, right? So if you will be able to recall, I think in your lower classes or when you were pursuing the bachelor's, or maybe after that when you were in the data specific domain, whether it be in a data science or data analytics specifically, you must have seen that we do have several methods to check the spread of a given data. Named a few if I will talk about. The very first method that is quite famous is what we have is standard deviation, right? And with the standard deviation, there comes one more word, which I think you must be aware of, called as variance, right? Both are somehow the tools to measure the spread of a given data with respect to a mean, right? So if you will just try to check the formula for both of them, so it is nothing but sigma, and this is represented by sigma square mathematically, right? So if you will just check the formula, it is nothing but summation of I is equals to 1 to n, the value of xi minus the value of, if you are talking about complete population, right, then you will take the population mean whole square, right, divided by the value of capital N, where n indicates the number of sample points that you have. And because we're talking about standard deviation, it is usually the square root of variance. So basically the variance is this exact value which I have evaluated, which is I is equals to 1 to capital N, right, where n is the size of the complete population that we have, xi minus mu whole square divided by capital N. So this is how basically we can evaluate the variance. So if let's say your data belongs to a normal distribution, so in that sense, what you are doing in a way that you are trying to check the spread with respect to the mean value. So you know that mean is something which belongs to the middle point. This is what we have as mean, if I'm not wrong. And always remember, whenever we are talking about something called as normal distribution, which is this current distribution is all about, having a bell-shaped curve, the value of mean, the value of median, the value of mode, all are equal to each other, which is the middle value. It indicates that it's a symmetrical data where 50% of your data lies towards left side of mean and 50% of your data lies towards the right side of mean. And these are the ways to check the dispersion with respect to the mean part. That's the whole idea when we're talking about STD and variance. STD is something which will talk about the number of units via which the spread is there with respect to the mean part. That is why you must have heard about empirical formula, if I'm not wrong, right? Empirical rule, which says that if a data belongs to normal distribution, and let's say if it is falling under the range of mu minus sigma to mu plus sigma, so in that specific range, almost 68% of data set will be available. Similarly, if we are talking about mu minus 2 sigma to mu plus 2 sigma, almost 95% data will be available. If we're talking about mu minus 3 sigma to mu plus 3 sigma, right, almost 99.7% data will be available. So might be I'm not able to create accurate, correct lines, but I'm expecting that you're getting my point. This is mu minus 2 sigma to mu plus 2 sigma range. This is mu minus 3 sigma to mu plus 3 sigma range. So what empirical rule says that in this specific range, 95% data will be available. And in this specific range, almost 99.7% data will be available. So this is one of the way via which we can detect the outliers. How? It is usually pre-assumed that if, let's say, any data which belongs outside the range of mu minus 3 sigma to mu plus 3 sigma, because you can clearly understand, right? This 99.7% data is already lied among this specific range. So if your data lies beyond this range, means beyond mu minus 3 sigma to mu plus 3 sigma, the probability of having this as an outlier is quite high. Now, many people might not get the idea very clearly that again and again I am saying in this video the concept of outlier. What is the meaning of outlier? Although I have indicated this in my previous videos as well, but still let me give you a brief recap. Outlier is nothing but, you can say, any extreme significant value. Okay? Any extreme value, it can be low, it can be high. Again, many people, I don't know, they pre-assume that outliers are always the extreme higher end values. No, it can be lower end as well. Let me give you a very simple example. Let's say you are doing a survey. Let's say you are doing a survey of people earning as a data scientist salary as a fresher. And let's say your survey is with respect to Bangalore, because it also depends city to city, right? Salary also varies, right? Maybe for Bangalore, let's say we are doing a survey and you get to know that you gave me a few numbers that, Priya, some people are earning as a fresher, let's say 12 lakh package, right? Then there are second person starting salary is 15 lakh. Third one you got 10 lakh. Fourth one you got maybe 16 lakh. Till so far things are fine because all of these numbers are somehow interrelated with each other. But you said to me that, Priya, there is one guy, which maybe I found it from, let's say, tier 1 college, or let's say tier 1 company they are working in, and they have a package of 1 CR, or maybe they are working in some international company, right, outside India. So that also might be the chance. That's why their package is too much, right? So in any of the cases, whether they belongs to tier 1 companies or colleges directly passed out from there, or they're working currently internationally. So in all of these scenarios, that person is an outlier, even though that person is having a very less experience, but still he or she is earning a lot of money as comparable to others belonging to similar level of experience, similar level of expertise, right? That's the main idea of outliers. Now, why we need to deal with these numbers? Because if, let's say, I'm the person who is doing a data analysis part and I am giving the numbers to the let's say clients, that what is the average salary of data science people earning in Bangalore specifically as a fresher, Because of this 1 CR number, my complete analysis went wrong. Will you guys agree with me? When I'm saying mean value, it is the average, right? So if you will try to take the average of 12 lakh plus 15 plus 10 plus 16 plus 1 CR, because of this 1 CR value, the complete value of mean will be much, much higher as comparable to when we don't have this 1 CR value. So completely the analysis went wrong, completely the mean value will went wrong. And that is why there is a lot of need to handle this in a quite efficient manner. Now, one way to handle this is that you can say that let's remove this. That's a good idea. But sometimes when we have a limited size data, removing directly the outliers leads to the loss of information. So sometimes it is fine. So if let's say you will be having a huge amount of data, right? You will be having a huge amount of data. And in this huge amount of data, there are, let's say, very small, I would say, number of outliers are available. Okay. So we have a huge amount of data, small number of outliers are available. In that case, if you're directly removing them, if you're directly removing the outliers, it's completely fine. It does makes a sense that you're directly removing it. It won't impact much because the proportion of outliers is very, very small. That's a good idea. But if let's say you are dealing with a small amount of data points, you are dealing with a small amount of data points, and in that small amount of data, you have outliers. So if you will directly remove them, if you will apply the same method, then in this case, it is not a good choice. Why? Because in this case, that will lead to the loss of information. Loss of information. That is why it is never ever a good idea in these kind of scenarios to remove the outliers. Maybe you can do data imputation, that will be a good idea, right? Maybe you can work around with a cost function, that would be a good idea. So there are multiple ways via which we can handle it, but the removal is not something which is quite apt. So one thing which you observe from this point, that it might be the case that for few data points, some strategy works good, but for few of them, it won't work the best. So you have to always understand that what is the kind of business problem you are dealing with, what is the kind of data set you are dealing with, what is the kind of domain you are dealing with, how much is the size of your data, all the decisions based on all these question marks which I have talked about. Otherwise, there is not a single strategy to handle all of these things, right? Now, two things I have talked about as the methods of dispersion, right? Methods of dispersion. One is the idea of standard deviation, another one is variance. Third one is again very simple, something called as range, which is the difference between what is the maximum value minus what is the minimum value. Now this measures many people are not using as a spread. Why? Because outliers are also depending upon the extreme ends, and this range also focuses on the extreme parameters of maxima and minima. So if the outlier are available, this range will always give us a wrong metric. The range will always provide us a wrong idea about the spread of my data, right? Again, take the above example, 1 CR minus 10 lakh is the range of a given salary, but this is not correct actually, right? Because 1 CR is an outlier. So whenever the outliers are available, so it is not a good measure in that scenario. It is not a good measure to check the spread of a data as and when the outliers are available. As and when, if the outliers are available in a given data. So always remember, if the outliers are available, range is not a good idea. If let's say your data is very clean, it doesn't contain outliers, then maybe you can opt for the range part. That's a good idea, right? Now, the last important thing, which is the whole and soul part of this specific video, is IQR. IQR is the difference between Q3 minus Q1. Q3 is the 75 percentile value and Q1 is the 25 percentile value. So if you will try to evaluate the difference between 75 minus 25, this will give you an idea about the spread of a given data. And this specific metric is quite robust with, or you can say with respect to the outliers. What is the meaning of that? That whenever you will be having outliers in a given data and you want to check the measure of dispersion or the spread of a given data, go with the IQR. Because the beauty about this specific matrix is that it is not dependent on the extreme ends, extreme minima or extreme maxima. It is completely depending upon what is the value available in 75 percentile and 25 percentile. Now, might be many people are not aware about how can we evaluate these values. So let me take a simple example and then I'll try to showcase you the further thing with respect to the outliers part. So this is a given data, let's say we have, right? This is a given data that we have. Now if I'll ask you, if you, first of all, if you can see this data is, I think, is in an already sorted manner, right? It's a sorted data in an ascending order. So if I'll ask you what is the value of median, median is nothing but 50th percentile. Percentile simply means that how many values are above this specific number, right? 50th percentile means middle value we are talking about. So how many number of entities we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Very good. So it means that it's an even number where the value of n is 20. The size of my data points is equal to 20. Now if I'll discuss, if I'll see that what is the middle entry, so I think it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So I will pick it up, I think 9 entries I have to leave towards the left side. So maybe till 78. 9 entries, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to leave towards the right side. So median is the combination of 80 plus 82 divided by 2. I hope you all know. This is how basically we can evaluate the median. And this is represented by Q2, quartile number 2. So if you will evaluate this, I think it will be 162 divided by 2, it will be 81. So if I'm not wrong, we will be able to get the 50th percentile number as 8181. Now, if I'll ask you what is Q1, what is Q1 and what is Q3? So in that case, what you will do is you will try to split this entry into 2 components now. So what you will do, you will take the first 10 entries in one cycle and the next 10 entries in another cycle. And if you will take from the first 10 entries, the middle value, that will be the Q1, 25 percentile, right? 50th percentile is the, in a complete data, middle value. 25th percentile means that you are splitting your data entries into 2 components. And in the first component, what is the middle value? Again, you have to evaluate the median only. So if I'll ask you what is the middle value here, I think here again we will be having even number. So 1, 2, 3, 4 if we will leave here. 1, 2, 3, 4 if we will leave here. So I think we can take this as a combination if I'm not wrong, right? So Q1 will be equals to 68 plus 70 divided by 2. Similarly, you can do the same thing to evaluate Q3. So you can leave the 4 values initially. You can leave the 4 values at the end and Q3 will become 92 plus 95 divided by 2. So whatever be the number you will be able to get over here. So in this case, it will be, I think 138 divided by 2. So it will be, I think 69 if I'm not wrong. And in this case, it will be 187 divided by 2. If I'm not wrong, it will be 93.5. Again, you can just verify at your end the calculations part. I'm not focusing much on that part. So if anything is wrong, you can just let me know, right? Otherwise, that's the main idea, to evaluate the 50 percentile value, to evaluate the 25 percentile value and to evaluate the 75 percentile value. Now, once we will be able to get this value of Q1, Q2 and Q3, let's deep dive into the value of IQR, which is nothing but the difference between, I would say, Q3 minus Q1 as we have discussed. So it will be 93.5 minus 69. So whatever be the difference which you are getting over here, that will be the final result which you will be able to get. So let's do one thing. So we will be having, I think, 93.5 minus 69 is the value. To be precise, we will be able to get the value as 24.5 if I'm not wrong, right? So this is the value which we will be able to get as the value of IQR. Now, this is a fourth measure of dispersion. Now, we want to detect the outliers with the help of this, and that is where we have a concept of creating a box plot. To create a box plot, we need 5 important points, out of which 3 we already have done, which is the value of Q1, the value of Q2, the value of Q3, which we already know for a given data. 2 other parameters are what is the value of upper whisker and what is the value of lower whisker. So how can we evaluate this upper whisker? The simple way to evaluate the same thing is that you will say what is the value of Q3 plus 1.5 times of IQR value. We already have all these values available, so we can easily able to determine that. Similarly, to evaluate the value of lower whisker, what you will do is you will try to see what is the value of Q1 minus 1.5 times of IQR. Today's challenging question for you all is, which I want you guys to do the research and explore on your own and give me the answer, that why in this specific formula we are multiplying it with 1.5. So let's see how many of you will be able to give me the correct answer for the same. Just try to explore, read the articles, read the research papers, and let me know that why it is exactly 1.5. Why not 1? Why not 2.5? Why not 3.5? There will be a scientific or experimental reason behind that. You can just let me know. But anyhow, let's move to the further video part. So here we will be having the value of Q3 as 93.5, right? Plus 1.5 times of what is the value of IQR? It is 24.5 if I'm not wrong. Now we have to do this calculation. And what is the value of Q1? Q1 is nothing but 69 minus 1.5 times of what is the value of IQR? It is again 20. I hope now it is visible, 24.5. So if you will try to evaluate this, right? So you will be able to get the number, which is nothing. But again, if I'll just try to solve this with the help of a calculator, 93.5 plus 1.5 into the value of IQR, which is 24.5 in our case. So we are getting the answer as 130.25 as the upper whisker. Similarly, if I will try to showcase you the calculation of lower whisker, it will be 69 minus 1.5 into IQR, which is 24.5. You can just again verify the calculation. My focus is majorly to explain you the concept. If there is any mistake, please let me know, right? So this is the upper whisker, this is the lower whisker. So how the box plot will look like now, you will be having a lower whisker, then you will be having a box kind of thing available, then you will be having a upper whisker. This lower whisker value is 32.5. The value of Q1, this is what we call as Q1. This is what we call as Q2. This is what we call as Q3. And this is what we have as the upper whisker value, which is, I feel, 130.25. The value of Q1 is 69. The value of Q3 is 93.5. The value of Q2 was, which we got as 81, right? So this is how basically our complete box plot will look like. Now, this box plot says that any value which lies beyond 32.5 or above 130.25 is a part of an outlier. That is why I told you, right, in the starting of the session itself, that any number as an outlier can be a lower value as well. So if any value which is fall below 32.5 is also an outlier. Now let's go back to our original data. So if in this original data we will see the upper whisker value is 130.25, and I can clearly see in my data 200 and 250 available, right? Similarly, lower whisker, I think we don't have lower whisker, lower value, but from this specific inference, we can indicate that 200 and 250, they both are the part of an outliers. This is the complete maths overall. Obviously, platform to platform, these calculations of Q1, Q2, Q3, specifically this lower whisker and upper whisker might vary. So don't get, amazed if you get some different numbers. For example, in Excel, in NumPy, they usually try to take the nearest range available in the given data set rather than taking a random number altogether. So don't get worried about that part. The main focus is the actual stats is this only. Now, platform to platform, internally things a little bit have changed. You don't need to take care of that part. Major thing is you have to focus on this specific aspect, that what is the original, I would say, way to evaluate these things for the platforms to make the things easier, to make the calculations easier. Internally, developers have interpret few things, right? That is something which I want to convey over here. So that if at any point of time in any of the platform you get some different value with respect to what you are getting as a calculated value via this, you won't be amazed or you won't say that my results are wrong. It is actually correct, right? You can just refer the documentation of that specific platform which you are using, and there you can check it out that how they are evaluating or what changes they have done, right, platform wise. That is the whole idea. Now, without wasting any time, what I will do is I will try to open the Excel over here in front of you, so that whatever things I have talked about over here, right, I will be able to showcase you in a great detail practically that how these things will be done, right? Here I have an empty Excel sheet available. And now what I will do in this specific sheet, I can take few numbers over here. Maybe let's take the numbers of the profit value, right? Profit which I'm getting from my company, the revenue, or you can say profit, whatever you want to convey over here. Let's say I'm getting the profit as maybe in the very first month, I got the profit as 1 lakh. Then I got the profit as, let's say, 2 lakh. Intentionally, I'm writing simpler numbers so that it will be easy to follow up, right? Then let's say I'm getting 2.5 lakh. And one thing, whenever we are doing the evaluation of a median Q1, Q2, Q3, always remember we have to sort our data. By default, while showcasing the numerical calculation or implementation, I'm taking a sorted data itself, right? If the data is not sorted, it might be the case, right? In your revenue, you are getting a lesser revenue in the upcoming month. So in that case, you have to first of all sort it out to get the numbers correct. Maybe let me do that for you all. Let's take here only 50,000, and then I will take again 1,50,000. Now it will become an unsorted data, right? Then maybe I will be having 6 lakh as the profit. Then I will be having, let's say, 8 lakh as the profit. And then maybe I will take 8 lakh as the profit. Then maybe I will take one extreme end value, which is 15 lakh. Or maybe 1 CR. Okay? 1, 2, or 1 million is also an outlier, right? So 1, 2, 3, 4, 5, 6. Let's take this number. Or it won't be an outlier because 8 lakh already I'm taking up. Let's take 1 CR. Okay? 1 CR value I'm taking up, so that I can showcase you also what is a part of an outlier in our case. So first part should be that given this data point, we need to sort it out. So we can click over here and we need to sort it, as I'm telling you, to evaluate the median, to evaluate the value of Q1 and Q3. Without sorting, you will always get a wrong result. So sort smallest to largest. As soon as you will do so, now your data is already in a sorted position. Once this is done, you need three components, Q1, Q2, Q3. So in our Excel, we have a function called as quartile, right? Quartile. Now in this function, you have to pass the data points, which is an array. Now you can see 0 indicates what is the minimum value you want, 1 indicates 25th percentile, 2 number indicate 50th percentile, 3 number indicate 75th percentile, and 4 number indicate maximum value. So if you will mention 0 over here, so what this number will generate you the minimum value. If you want 25th percentile, so what you supposed to do over here is, you're supposed to mention equal to quartile, and here provide the range and then mention the value of not Q2, 1. This will provide you the 25th percentile. Similarly, if you want 50th percentile, so what you're supposed to do over here is, you can say equal to quartile, and similarly you can pass this range, and then you can say I want 2. This will give you 50th percentile. Similarly, if you want 75th percentile, so how can you do that? You can mention equal to quartile, and here again pass this array and mention the number as maybe 3, right? And similarly, if you want the maximum value, right? If you want the maximum value, so in this case, what you can do is, you can just mention equal to quartile function, again refer the array specific range, comma, what is the again number which you are looking for is 4, just close this. So in this way you will be able to get minima, maxima, 25th, 50th and 75th. Now if I'll ask you, what is IQR? So you know IQR is nothing but is the difference between 75th percentile value minus 25th percentile value, and you will get the value of IQR. Now if I ask you what is the value of upper whisker, right? Upper whisker. So it's again very easy to evaluate that. So maybe what I will do this analysis maybe below, right? So upper whisker is nothing but what is the value of Q3, which is this, plus 1.5 into the value of IQR. So you will be able to get the upper whisker value. Now upper whisker is 14 lakh. I will say 18,750. Lower whisker in this specific scenario is, what is the value of Q1 minus 1.5 times of IQR, and you will be able to get the value of lower whisker, and this seems to be a negative number. Makes sense, it might be the case, it can happen. Now if let's say you know that any number which is beyond this range or below this range will be a part of an outlier, which seems to be this 1 CR, right? So if you want to plot this as a box plot and try to check, so what you can do is, you can go to the insert button, recommended charts. I want to see all the charts, so maybe I will go over here only. I want all charts. Go to the all charts part. Let me big this screen. There is an option of box and whisker. So if you will try to plot this, right, just click on OK button. See this very carefully. And this is the beauty about box plot. And that's what I want to convey in this complete session. So here you can see, right, this is the single outlier. So with the numerical calculation also, we got this as an outlier. This is the highlighted point, right, as an outlier. And in this image also, if you can see, this dot indicates an outlier. So how easy it is, even though if you will not do this calculation, just via creating a box plot in your Excel sheet, gives you an idea that, okay, what is the outlier available, right? So in this specific manner, the complete idea of outliers detection is pretty much clear to everyone. I am expecting that part. So basically what things we have learned in this complete video, we have talked about the measures of dispersion, in which I have started my discussion, if you remember, with respect to the standard deviation, variance, range, and IQR. If you remember, we have talked about empirical rule in between, where I have showcased you one of the way to detect the outlier is that if any data point, if it follows a normal distribution and falls beyond the range of mu minus 3 sigma to mu plus 3 sigma, that is also an outlier. After this, if you remember, we had a great workaround with respect to how to evaluate Q3, Q1 with the help of one dummy data. Afterwards, we have talked about how to evaluate upper and lower whisker to create a box plot. Box plot is composed of 5 important components: Q1, Q2, Q3, upper and lower whisker, right? Afterwards, we have seen that in this specific data points, we have observed 200 and 250 is a part of an outlier, right? At the very end, we have seen, if I'll take this as the, specific values, not this I want to create a bold and all borders, and I want to highlight this with the different colors. So this is the major analysis that we have done, and afterwards, this is the major analysis that we have done, right? So we have seen that how can we evaluate all of these things. What is the value of 0 quartile when I am entering in the function 0? 1, 2, 3, 4, right? Minimum, 25th, 50th, 75th, maximum. How can we evaluate the value of IQR, upper and lower whisker? How can we create a box plot to get the final idea? This is the overall idea about this video. Might be a long video, but I hope that you find this video pretty much insightful. You can just let me know what are your thoughts and whether you got the idea which I want to convey over here or not. You can observe over here, I have not used any coding part per se. I have just used the numerical interpretation plus the Excel tool interpretation of quartile function, and with the help of which everything seems so easy. With this, let's end today's video. I will see you all very soon in the upcoming videos. Bye bye everyone, and see ya.